So last one, here we go. This one, the domain is all real numbers. The range, -1 to 1. Symmetry is the origin. We can do that by actually testing out their test for symmetry. Or again, we can see that from the graph once we get there. So same with the range. We'll come back to that. X-intercept is 0, 0. Y-intercept is 0, 0. Derivative is a little more complicated here, so I did the quotient rule. Bottom times the derivative of the top minus top times the derivative of the bottom. I've got to do the chain rule over the bottom squared. And now so I can rewrite this in this form. So I multiply the top and the bottom by the root x squared plus 2 to simplify this a little bit. And then actually, again, it simplifies pretty nicely. So the first derivative ends up simplifying to just y prime equals 2 over the square root of x squared plus 2 cubed. So then I can do the second derivative where I will not do the quotient rule. So I will first think of this as 2 times x squared plus 2 to the 3 halves. I'm sorry, to the negative 3 halves. So then I will bring down negative 3 halves, x squared plus 2 to the negative 5 halves times 2x, and then rewrite this. So the second derivative is negative 6x over the square root of x squared plus 2 to the 5th. So now I'll find my critical values. 2 does not equal 0. That's not a critical value. Square root of x squared plus 2 to the third equals 0. That is also not going to give me any critical values. That just gives me imaginary numbers. So none. So there's no relative max, no relative min. Possible points of inflection. So that's easy, right? That makes things a lot easier. A lot less derivative speak there. Anyway, possible points of inflection. Set the numerator equal to 0, set the denominator equal to 0. Denominator is not going to give me anything for the same reason it didn't over here, but the numerator gives me a possible point of inflection at x equals 0. Now I'm going to do a concavity chart. So I have 0. I plugged in -1 and 1. It changed from positive to negative. Therefore, I have an inflection point. So since f double prime of x is greater than 0 on negative infinity to 0, and f double prime of x is less than 0 on 0 to infinity, the point is 0, 0 is an inflection point. Vertical asymptote, none. Horizontal asymptote, y equals 1 and y equals -1. I can get these by doing the limit as x goes to infinity and the limit as x goes to negative infinity. Why would a limit of infinity come in handy? Oh, because I found a horizontal asymptote. That's why. People. Anyway, so here's my graph. I've got my inflection point, which is also my x-intercept and my y-intercept, and my horizontal asymptote, my other horizontal asymptote, and my curve is going to look like this. So going back to what I said earlier, this is also how I found the range, which is -1 to 1. And I can see the symmetry as well. Look at that. That's beautiful. Nice symmetry. All right, so who knew that all of this stuff could be found out about a polynomial without a calculator, right? That is exciting. You can hear the excitement in my voice. I'm excited, thrilled. Okay, we've got a test coming up. But you'll be great. You got this.